Welcome to my first Box2D tutorial. Box2D is a 2D physics engine. Physics engine is pretty much mean that it will handle your collision and movement of your object. So far we did some kind of physics like make the falling by increasing the y value of the object, so it seems like it is falling. We made some collision detection, so with oriented boxes like we did in the side scroller game. Although this is working, but it's not really the best effect. To get the best effect, your object will rotate and have all kind of weird effects, like a chain, for example. It will be really complicated to make a chain from a lot of little segments by manually. So that's why we will use a library called Box2D, which is a physics engine, as I've already said, and it will handle all of your collision, all of your forces and torque for an object, and so on. So for example, here is an example which would be a little bit more complicated to make in the code. So for example, a box falling down to another box. In the side scroller game kind of method, we will just stop this object right here on this other object, which would be not too realistic, because all we know that if this object falls into this other object, it will just rotate like this and bounce off, and it will depend on a lot of variables like the speed of the two objects, the bounciness of the two objects, the friction of the two objects, and the current rotation of the two objects, and so on. So a lot of variables, and it would be really complicated to make. And this is just a simpler effect. A more complex effect, like when you create a chain or a rope from a lot of little line segments, which will be complicated. So let's start with the tutorial. First of all, we should download the Box2D. To download it, just go to box2d.org, right here, box2d.org, and click on download. Here is it. In this address, and here is the Box2D v22.1.zip right here under the screen recorder right here. Okay, and just download it. Right, so after you have downloaded it, right here I just downloaded it, so now we can actually uncompress it, so just extract it. Right, and we get a folder called Box2D v2 so on. So here you will find a lot of things like the documentation, which is very useful. Here you can find the manual, which I recommend to read. It's not that long, it's just 66 pages long. Okay, and in this folder there is a testbed folder, which is really useful. Here under this test there are a few programs, although these seems to be header files, but actually they are C++ program, as you can see. So you can pretty much just use this, although with a testbed, which I will show you soon. So you can take a look how every effect, like the chain or the bridge or whatever, are actually made in the code. Right, and what else? Of course, we need to install the Box2D. To install the Box2D, there is a build folder, by the way, right here, which is give a build solution for the Visual Studio 2010, and you can pretty much open this up with Visual Studio and just compile the project, and I guess it will give the result. And you can open this solution right here, maybe with code blocks, and compile it, and it will give you a static library like libbox2d.a or something. Okay, but let's make it in Windows with the terminal, because what else would we use to make it? And of course I will show you how to make it in Windows. So let me go into this folder, so Box2D, and the name is Box2D, right, and let me create a directory with mkdir, like make directory, which is called build. Okay, and let me go into this build. Okay, to actually install this in Linux, that's quite simple. You can use this cmake lists file, and this file is for the cmake program. I'm not sure if it is installed here, so cmake, no, it's not installed in here, but you can install it with sudo apt-get install cmake. Right, and just install it. There is a similar way to install it in Windows as well. You can download this cmake program for Windows, and there is some cmake GUI or whatever which you can start, and you install it basically the same way. Although I will show you a little bit of different method, which is use code blocks to install it in Windows. So make a static library basically. Okay, now that cmake has been installed, just write cmake and then a dot. Okay, and this pretty much will we are in the build folder, so the dot will pretty much get the cmake.list and build and make it. Right, and this will look for thing, and as you can see, it's already finished. So I guess we can just make it with normal make. So sudo make, and this could take a while. I pause it. Perfect, it is already make. So to actually place these built-in static folders into the correct place, I just use sudo make install. And by the way, you get maybe a few warning like replace conversation from string constants to charges. Don't care about this. Okay, and yeah, that's pretty much did the trick. Although there is a little problem, it's put into the local folder, so it's /usr/local, and I don't really like if it is there. So I will just copy this Box2D folder into my usr/include folder. So sudo cp to copy and /usr/local /include /box2d, and I should use the /r to copy the folder and everything in it to the /usr/include folder. Perfect, and then I do another copy, which is, and in this case I will copy from the local /lib folder something libbox2d.a. This is the library file which we are going to use with box2d flag in the compiler. So I will copy this to /usr/lib. Probably there is an option in CMake to where to put these files. And /lib/ perfect. Okay, the program is already installed. So now if you go into this build folder which we have created, here you will find this testbed. There will you find this program which I told you about earlier in the testbed/test folder. So all of the source code is in the testbed folder. But here you can actually take a look how these programs are actually look like. As you can see, you can actually choose quite a few programs right here, and you can take a look. And if you don't know how something is actually made, then just open up this that folder which I showed you earlier and check the source. Right, so what is here? There are a lot of things in here, gears, and usually it writes somewhere here to how to control this object, like you can control it with mouse or something. Yes, right. So there are a lot of programs here. Cool, chain. Right, that's about it. So you can test, so you will find all of the source code in this testbed folder if you want to know how each of these work. And then now I should cut here how I installed it in Windows using code blocks. All right, now that it is installed, we can actually go and make some useful things with it. So I just open up the main.cpp. I will use OpenGL, or alternatively I write just the pure SDL version, because I cannot make my mind if I should use OpenGL for this or use SDL for this, so I actually make both. And in the beginning I will use OpenGL, and throughout the series I will use OpenGL, but of course you can follow along with SDL, or you can use Flash and so on. Basically it works with everything. It's just a pure C++ code, so there is nothing dependency on this like OpenGL need a graphic card or something. It's just pure C++ code, so you can pretty much compile and run it everywhere where you can compile a normal C++ code. Okay, and it doesn't have any graphical output, so we have to actually manually, so we have to use some external libraries to actually draw the graphics. It would work without actually drawing anything, but you could just write out the position to the terminal or something, which is not too useful and not too pretty. So here I just write a normal OpenGL program right here, and the init and the display function currently are completely empty. And what I do here is basically if I press escape or press the X in the corner, I will just quit the program, and pretty much that's all. I call this init function before the main loop and the display function in every loop, so I can write something in here, for example in this init function. So let's just initialize OpenGL. I will not initialize OpenGL how I used to initialize with perspective projection, because now we are pretty much using just 2D, and for 2D there is no reason to use perspective because that's for 3D. So we will use something called orthographic projection, which is a special case, and instead of a normal viewing volume like you had, if you remember, volume like this in case of the perspective, I will just use a simple cube, actually not cube but a box. So here is box, and you define this box with the 4 planes which make up this box. So about this. Okay, so here is it, and you just define it with the 6 planes which make this up. So we can use the GL matrix mode to go to the projection matrix, and then you just make it back. So GL matrix mode and GL model view, and here in the middle we will define the coordinate system, basically that cube which we are going to use, with the function called GL ortho. This is not in the GLU library, although there is a similar function in the GLU library called GL ortho 2D, but we don't have to use this because it's pretty simple to set this up. So first of all, it's waiting for the left and the right plane, which is 0, and the width. Actually, let me make a constant for this. So const int, and it's called width is equal to 640 because that's the width of the screen, and const int height, and this is equal 480 because this is the height of the window. So it's first waiting for the left and then the right plane, which is width. Then it's waiting for the bottom and the top plane. Now I will do so you could write 0 and height right here, and this will pretty much mean you have the same coordinate system as you used to in OpenGL. So you go up from the bottom because you set the bottom to 0, so that's the center of your coordinate system. So the coordinate system will use look like pretty much the same as it look like in OpenGL. So it goes from the center point, which is right here, for example, at the bottom of the window, to the left and to the up. Now I want to the coordinate system to be same in the SDL, so it will start from the left top corner instead of the left bottom corner. To do that, I will just simply swap the bottom and the top plane. So I write the height first and then a 0. Okay, and the last is pretty much the far away plane and the near plane, or should I call front and back plane. To define a front and back plane, you pretty much have to make the first value a little bit less than 0, because we will draw it in 0 coordinate because we work in 2D. And the second, so the far plane or the front plane, is a little bit higher than 0. I will choose -1 and 1. It's pretty common to use -1 and 1 if you are using using 2D. Okay, and let me just set a clear color as well. So GL clear color, and just set 0001, so it will be black. Okay, and that's pretty much it about the init function. Now I haven't done anything with Box2D, so because this is a Box2D tutorial, it would be time to start. Okay, so first of all, I have to include the Box2D, and to include the Box2D, I will include the Box2D slash Box2D.h. This is capitalized as well. So Box2D. Like that. So now I have included the header file for the Box2D, so now I can use the Box2D functionality. So first of all, we have to create a word. Word is pretty much everything which Box2D handle. Usually there is just one word in a game, and I will make it dynamically allocated at runtime, so I can control better when to destroy it. To make a word, I use just b2 word, and actually, as I said, I will dynamically allocate, so this will be a pointer, and I just call it word. I make it globally, so I can access it from any function. I don't have to pass as a parameter everywhere. So the word is pretty much every single body, every single object which you add the game, and every single joint. I will talk about that later. So the Box2D uses this word to actually simulate everything. So you add the bodies, the objects, to the word. So that's why we need this word. And in the init function, let me initialize it. So word will be equal to new and b2 word. By the way, class name usually starts with b2 in Box2D. So b2 word, and it's waiting for the gravity in the word. That is the only parameter. In older version of Box2D there were a few additional parameters as well. To give it, it uses a b2 vec2, which is basically a vector, two-dimensional vector. This is the name, b2 vec2, and it's waiting for the xy coordinate. So the gravity in the x direction will be 0, since there will be no force in the x direction, and the y direction it will be, I don't know, 9.81 usually gravity on Earth, although that may be a little bit too big. Right, and actually After this display function, let me actually call one important function, which is basically the update function of the Box2D. This is word, and then here step with capital S, and this step function waiting for 3 parameters, and basically this is the update, so I could write it in here. If you don't call this step function, then it will pretty much not move, so you can add bodies but nothing will move, so it will be like a static scene, and you don't want that, so you have to always call this step function. The first parameter of this is actually the time to update, so basically it's waiting for the time between 2 frames. So I just write 1 divided by 30 because 30 is basically the number of FPS. As you can see here, I regulated it, and 1 is just 1 second, so how many times basically it should update. So it should update the scene in every 1/30th second. Okay, the second parameter, by the way, you shouldn't change this number, so it should be always a constant. I could make a constant right here, but I just write 1 divided by 30 right here, and if you change this number, the stability of the Box2D could be worse. Okay, the second and the third number is basically the number of updates, so there is some called velocity update and I don't know, movement update or something. I just write 5 into here. So basically all you have to know about these 2 parameters, if you make it higher, the more precise the calculation and the response will be, but it will run the game or the program slower as well. So you just have to find a good number. 5 is working well, I believe. 8 and 3, which the manual suggests, so I could write 8 and 3 right here. Okay, now everything is simulating, everybody is falling and following the Newtonian law of physics, but there is one problem: we don't have any body. So let me help with that, and let's make a function which actually make bodies, and actually it will return a B2 body. B2 body is basically a pointer to a B2 body, so it's basically just a handle or basically the body itself, and I will return a pointer to a body. Okay, B2 body is obviously the body, and I call it add rect, like add the rectangle. For now, in this first program, I will only add a rectangle. Later on, I could add a circle or the edge shape. To add anything, anybody basically, you have to do the following. There are 4 steps to follow. The first is basically to create a body def and set the property. So this body def is basically a simple structure. You can set things like the position and the type in this. Like the position is obvious, and the type could be 3 different things, so position and type. The type could be 3 different things, like the static object. The static object is basically which one is not moving. The dynamic object, which is basically whatever is moving and react to force and have collision. And there are a final one, kinetic, which is basically just some hybrid between the two. So the kinematic body could move and but do not react to forces. So basically if there is a collision, it will do not react for that. So for example, a platform in a game, you know, that moving platform which move left to right and so on. So that is the kinematic body. So let me actually make one of these body def. To make a body def, I use B2 body def structure, and actually the D is capital as well, and I just call it body def. And as I said, we can set the properties of this, like the position. By the way, one thing I should mention is you should check the source code, actually, mostly the header files. Right here, if you go to the Box2D folder and in the Dynamics folder, you can find actually all the source code and all the header files, and these are really well coded and nicely commented files. So if I go here to the B2 body, as you can see, there are a lot of comments right here, and here I can find the body def right here. So you can set all of this data using the body def, like all of this. So you can use the position.set to set the position. Actually, let me get the position as a parameter, so int x and int y. And to set the position, I just use body def dot position dot set. Nice. Position dot set, and just set it to x and y. And yeah, that's pretty much it. The next is what usually which you should usually set is the type right here. The type is default is static body, which is usually not the right way. So you usually want to have dynamic bodies. Of course you want to static bodies, right, like the ground, but you also want dynamic bodies, so you will usually set this type to the type which you want. Okay, and let me get it as a parameter, so bool, and I just call it din. Like if this din is true, then it will be a dynamic body. And actually let me get the width and the height of this rectangle as well, so int width, int height, and lastly the dynamic body, and set it to true by default, because most of the time we will playing around with dynamic bodies. So I set the position, and the next thing to do is to set the type. So the type is equal only if the din is true. So if the dynamic body is true, then I set the type to a dynamic body def. To do that, I use b2 underscore dynamic body, like that. Okay, now it is a dynamic body, so it will fall and react to gravity and collisions and so on. The next step to create a body is to actually create the body with the world and create body, and is waiting for the pointer to this body def which we have created. You can create multiple bodies with the same body definition. Okay, so let me actually create a b2 body, and I call it, I don't know, body, whatever, and use the world and create body, and it's waiting the pointer to the body definition. Perfect, I have created a body. Although, as you may have noticed, we do not use the width and the height. That's because a body do not have a shape, which is kind of weird because bodies have shapes. But in Box2D you have to do 2 additional steps to add a shape to a body. So the 2 additional steps is to first create a fixture definition, which is kind of like body definition. You can so for the fixture definition you can actually set the shape and other parameters, or shape and other parameters, and finally you use the body and create fixture. The fixture is basically whatever is on the body. So how does it look like? You can actually assign multiple fixtures to the same body. Right, so let me actually create that. b2 fixture def, so the fixture definition, and I just call it fixture def. Right, so now we have a fixture definition. So you can actually set several parameters. Again, I suggest to go to the source code if you want to see all of these. So in the fixture, and right here in the fixture def, so you can set the shape and friction, restitution, density, and sensors, user data. These are the parameters which you can set. The shape is, as you can see, is a b2 shape pointer. So let's actually create a shape right here after that. So we could use the b2 shape, although we couldn't really use because we need a specific shape, and there are classes which inherit from this b2 shape, like b2 polygon shape, which we are going to use, which is a polygon. There are also b2 circle shape and b2 edge shape and a few others, but I will use polygons for now because I want to add a rectangle, and I just call it shape. Okay, and you can use shape is equal, so you can actually assign vertices for this manually. Again, check the source code for the collision shapes and polygon shape somewhere here, polygon shape, and here you can find a function like set as box. We are going to use this, which is, as you can see, wait for the half of the width and the half of the height. Alright, and as you can see, you can actually add points manually by using the function set right here. Right, but I will actually use the set with capital S, set as box, to set it as box, and it's waiting half of the width and half of the height. So width divided by 2 and height divided by 2. Perfect. Right, what else? Pretty much that's all about the shape. You can set it the vertices manually, or in case of circle you set the position and the radius, but for now I will just make it a rectangle. Now in the fixture def, so fixture def, and make the shape equal to the address of the shape because it's waiting for the pointer. And we also want to change the density. Density is basically the density. So how Box2D calculate the mass of a object is basically get the area of the object and then multiply it by the density. The density, if you go here to the fixture, as you can see, defaultly it is 0, so the mass will be 0, and so pretty much it will not react to gravity and anything else. So change the density, so fixture depth dot density, and change it to 1.0, so the mass of the body will be the same as the area of the body. Right, and one last thing is remaining is to create the fixture. So body and create fixture. Okay, so and here it's only waiting for the fixture definition pointer. So fixture definition pointer. Right, that's pretty much it. We have added a rectangle. I'm pretty sure it should add this rectangle right here into the object. So these are the steps which you have to go through in order to add something, even if it is a circle or something else. Okay, and now we can add, and all of these objects will actually fall down and react to gravity, except if they are not dynamic, so they are static. But we need a way to render it, because so far it's cool that we have if we have created objects which are falling, but we didn't actually render anything. So in the display function, I use a while loop to actually go through all of the bodies in the world. So before I do that, let me just clear the window. So GL color buffer fit, so it will be cleared, and load the identity, GL load identity, and I'm pretty sure this is not needed. And then OpenGL actually, Box2D actually uses a linked list to set the vertices. So what the linked list is meaning, although I haven't made a tutorial about that, that there are several bodies. So this is body 1, body 2, body 3, and body 4, and every body actually every single body actually contains a pointer to the next one. So this first is pointing to the next, and the second pointing to the third pointing to the fourth, and finally the last is pointing to null. So this is null right here. We can get the pointer to the first body with a function from the word, which is word.getBodyList, which is basically the pointer to the first element. And then from there we just basically go through the entire chain until we find the null. And for every body I basically will just draw that. So let me make it. So I will need a B2 body, and I call it TMP whatever, and this TMP will first of all pointing to the first object, and then the second, third, and so on, going through the chain. So first of all I use the word and get body list, which is basically, as I said, is the first element. Then I use a while loop, so while this TMP is not equal to null, so while TMP is not equal to null, then until I get always the next. So but TMP equals to TMP get next, which is basically the next. And so this is how we go through a linked list basically. Okay, and the next is to actually draw it out. So I will call a function called drawSquare. DrawSquare will waiting for 4 points, which is basically the 4 vertex of the body, the center point, and an angle. So actually we need to get the 4 vertices of the body. So let me just create a B2 vec2. As I said, this is basically the vector to the object in Box2D, and I can just call it points. And these points will have 4 elements because we just add rectangles. So every rectangle have 4 elements right here. Rectangle. Every rectangle have 4 vertices. So I use a for loop. For int I equals 0, I less than 4, I plus plus. Of course, if you add circles, you have to check if the current body is a circle or something. But for now, I'm pretty sure we only have rectangles, so I can just use a for loop to get the 4 vertices. So points I equal to the current vertex. Now to get a current vertex, that's a little bit complicated. You have to get the TMP, and then you get the current body. You get a fixture list for that. So get fixture list, which is basically giving back the first pointer to a fixture list. Similarly than bodies, Box2D uses a linked list to store all of the fixtures as well. So to store all of the get fixture list will pretty much pointing to the first fixture, which is exactly what we need because we have only one fixture. As you can see, we only call the create fixture only once. Then I get the shape from it, so get shape. Now the get shape will pretty much now pointing to this shape right here, B2 polygon shape. Now we have the shape, and now we have a B2 shape. So a B2 shape is not a polygon shape, so we have to cast it. So I use a B2, caps lock, B2 polygon shape casting, and I cast this pointer to a B2 polygon shape. To make the order of these, well, I use parentheses right here. So now we have the polygon shape. Now we only need to get the current vertex. So get vertex to get the vertex, and this waiting for one integer which is telling which vertex do you want to get. I want to get the ith vertex, so the point 0 will be the 0th vertex, the 1 will be the first, second, third, and so on. So now I have got all of the points. Now here in the draw square function, we can pretty much just pass these points right here, points. Then the second parameter will be the center position, which we can get with using tmp get world location. Get world center. So if again we go here into the B2 body, you can find the B2 somewhere, get world center right here, get the world position of the center of the mass, which is exactly what we need. So get world center, and this doesn't wait any parameter. And the last parameter is the angle. Again, we can use body and get angle. This doesn't wait any parameter. Okay, so again you can come here and check if it is really exists right here in the body b2 body.h. Right, so we only need to make this function and we are ready for a test. So let me make this function right here. It will be relatively simple, and this will be a void function. It will be using OpenGL, so pretty much most of the stuff which I have covered, except this init function, is pretty much multi-platform. So wherever Box2D run, you add the same way the rectangle, and you probably use similar display function, except this clear and load identity. But the rest of these are pretty much work in SDL or OpenGL or whatever. But here this draw square function will be only using OpenGL. So first of all, let me just make the current color 3F to white, so we can easily see the rectangle because the background is black. So I use the GL push matrix, so I will not screw up our transformation matrix, and GL pop matrix at the end. Okay, and I translate to the center coordinate, which is, oops, I should write points right here. This is a B2 vec2 pointer points, and then the second is a B2 vec2 and center, and the last one is a float angle. Alright, so right here I should go to the center location, so GL translate F to the center location, so center.x, center.y, and center.z. So now I am in the center location, and I will rotate after that. Remember, if you rotate after the translation, it will rotate in place, so it will not make a big circle like this, but it will rotate in place. So GL rotate F, and I will rotate with angle times m times 100 divided by m underscore pi, because this angle which Box2D use is in radian, but the angle which OpenGL use is in degrees. So we have to convert the radians to degrees, and we can do that by multiplying the number with 180 divided by pi, and we rotate it on the z-axis, because remember, the camera in OpenGL looks at the negative z-axis. Almost there. We only have to draw the object. I will use immediate mode for drawing the object with GL quad, and I just go through all of the points and draw a vertex there. So for int I equals 0, I less than 4, I plus plus, and I just use GL vertex, and now I use 2f, so not 3f. The 2f is same as 3f except with the 0z parameter. So right here I just points I dot x and points I dot y. Probably you have noticed that B2 vec has the x, y, and z parameter, which are public, and you can get, and so similar than vector 3D, which we have created, except it's two-dimensional. I'm pretty sure we are finished. So one last thing is remaining, is to actually add squares. So right here, when for example I press the button, so let me make another event for that. SDL mouse button down. This happens whenever I click with the mouse, and then I just add a square or add rect, or what was it? Add rect. Draw square, add rect. We should call it draw rect. Anyway, so this first waiting for the xy coordinate, which will be event.button.x and event.button.y. Okay, and secondly, it's waiting for the width and the height, and which should be actually, so we have to actually convert the pixels to meters, because Box2D uses meters instead of pixels. So I usually make two constants for this, so const float and pixel to meter, and another float, const float and meter to pixel. Okay, the pixel to meter is pretty much how many pixels there are in a meter. The meter to pixels is pretty much how many pixels do we have in a meter. So for example, if your character is 100 pixel height, has 100 pixel height, then you pretty much want to choose something like 60, because let me get a calculator, because 100 divided by 60 is give about 1.6, which is about an appropriate height for a person in meter. Okay, and there is another function which is pixel to meter, which is basically just the inverse of that, so 1 divided by meter to pixel. Okay, so these two constants are actually needed to convert the meter to pixel and the pixel to meter. The manual pretty much suggests that you use meters instead of pixels, because, for example, in case of a 100 height player, Box2D will pretty much see the player as 100 meter tall, which is a little bit big. So in order to keep every calculation precise, you should use you should convert the pixels to meters. And to convert, it will be just as simple as multiplying by meter to pixel or pixel to meter, depending on whatever, but if you have meters or pixels. So for example, right here in the add rectangle, instead of setting the position to xy, I set the position to x times pixel to meter and y times pixel to meter. Okay, and in here, for example, when I set the shape right here, I just convert the width to meter, so pixel to meter times width, and here pixel to meter times height divided by 2. And for example, the rest of this could stay untouched. Right here in the draw square function, I have to do the opposite. So instead of so I have to convert it to pixels. So multiply it by meter to pixels and multiply it by meter to pixels, and here as well. So basically, because the meter to pixel is the opposite of pixel to meter, if you multiply these together, you get 1. So in the center, so we set the center to meters, and then we set the meter back to pixels whenever we draw it. It seems like a little bit of waste of time to always multiply, but actually it's needed, because Box2D, although it probably will work, it will be less precise. Okay, and here when I set the vertex, here meter to pixel as well, and here too, so multiply meter to pixel. Alright, so again, we can actually put event.button.x, we can actually put now the rectangle. Now the width, make it 20, width and height 20 as well. And was it any other parameters in the add rect? Yes, the dynamic, so set the dynamic to true. And that's pretty much it, although I'm pretty sure now the object will just fall down, because there is no static object which will stop them. So in the init function, let's add the static object, and that will be the last one which we have to do. Let me move down the init function, so we don't have to use function prototypes to call this add rect function. For example, above the display. Okay, right here, let's add an object. So I use an add square function, add rect function again, and this add rect function will waiting for the xy coordinate, which will be the x coordinate will be 0. No, width divided by 2, width divided by 2, because in Box2D you start to define the rectangle from the center point, so you pretty much give the center point of the rectangle, which is width divided by 2, because I want to make a platform right here in the bottom of the screen. So I start from the center. It will be, I don't know, 20 big in the height. Then, actually, no. This will be, for example, height minus I don't know, 50. Okay, so it will be somewhere in the low, somewhere will be low on the screen. Next, the width and the height. Width will be divided equal to width, and the height will be equal to 30. And this will be a static body, so set it to false. Right, I'm pretty sure we are finished. We only have to debug it if it is needed. I also use the Box2D flag. Make sure to use the capitalization right. The B and the D is capital. Okay, not that many error. So B2vec2 has no name. Of course, there is no Z. Why I wanted to translate in Z. So in Z, just pass 0, because we are in 2D, not in 3D. Okay, and alright, that was one. Where is my terminal? Did I close it? No, it's here. Okay, GL color. Okay, because GL color 3F. Yeah, GL clear color, clear. Right, and then we have a B2vec instead of B2vec2, so B2vec2. And lastly, body was not declared in 16.9 row square because it's called TMP. Not sure why I always want to call it body. Okay, so I'll now compile it and try to run it. And here is the little platform, and we can drop objects to it. Seems like we screwed up somewhere, because this object seems to be too heavy. They are almost going into each other. Not sure where we screwed up, maybe with the speed. Probably the 60 is a too big number. Let's make it 20, for example. Maybe that's work out better. So let me run it and try to drop boxes. And it seems that it's working. As you can see, where I click, I can drop a box, and they are pretty much colliding, and it's working well. Welcome to my first. Now, for those of you who want to use Box2D with OpenGL, this tutorial is pretty much over. I think the result is quite nice. We don't have to code that much, and it is acceptable. So you can add dynamics to your game. Of course, there will be a later few tutorial, when I will add other things to this to the program, like bridge and chains and joint and stuff like that. But for now, I think this result is quite nice, and we don't really have to code that much to achieve this result. Right, so for those of you who want to use it with OpenGL, this tutorial is pretty much over, because now I will show you how you can set up it with SDL, so pure SDL without any OpenGL. So I have opened up this line.cpp file. This is from one of the earlier tutorials to draw a simple line, and I will just copy this because my plan is to draw the outline of the object. It's a bit more complicated to fill in objects in SDL than OpenGL, because OpenGL pretty much did that automatically for you, while in SDL you would have to code a lot for that. So I will just use the outline of each object. And by the way, you can use images and rotate the images, and then you will have textured and filled in objects. Similarly, in OpenGL you could use the load texture function and use textures instead of just simple polygons. Right, so I have this draw line function, and now I only have to draw a rectangle. So let me make a function for that. Draw square right here. This is similar than this is, so I will just copy this. Draw a rectangle, and actually just the definition. Okay, so what I have to do is go through the points and draw a line from the previous point to the current point, or from the current point to the next point, whatever you prefer. So I use a for int I equals 0, I less than 4, I plus plus, and I just use this draw line function to draw a line to the screen. I will make this screen global or something. And then the next parameter, if you remember, is the xy coordinate, so or the start coordinate. So points I dot x and points I dot y. Right, and the next points are the endpoints, which will be I plus 1, although there is one problem. If this I plus 1 is greater or equal than 4, then we pretty much address outside of the array, which we don't want. So in this case we want to address back to the first address, the first element, so we pretty much enclose the object. So to do that I will just use if I plus 1 is greater than 3, then so use a question mark, then we just make it to 0, else make it to I plus 1. So what it will do is basically, if you remember, probably you already know that this operator which has 3 operands, basically an if then else. So if the I plus 1 is greater than 3, then I just get the zeros address, else I get the I plus 1. Similarly right here, so I will just copy this to the y. And that's almost everything which we have to do. As you can see, it's quite kind of simple, and we don't really need this other draw square function, and in the init we don't have to set up the OpenGL. Okay, in the display we don't clear the screen in this way, but we use the GL SDL underscore rect field rect, so SDL underscore field rect, which is waiting to the screen, and the second is null and the first is just a 0, so it will be black. Okay, that's pretty much it. Okay, we have to make an SDL surface global variable which is called screen, so SDL surface and screen, and I should initialize it in the main, so whenever I use the SDL set video mode, so screen equal to this SDL set video mode, and now I use SDL SV surface. What else is remaining? We don't need to call the SDL GL swap buffers, but instead of we call the SDL flip screen to show the content. Okay, and almost there. We only have to rotate the object, because that's one thing we have to do, because in OpenGL we do the translation rotation. Now we can't really do that because we don't use OpenGL, right? So we have to manually write a function which rotates an object, and actually if we are there we can actually translate the object as well. So let me create a function right here, void, and I call it rotate translate. Okay, and this rotate translate function will wait for vertex, or actually waiting for, so yeah, vertex. So this vertex will be a b2 vec2, so this is a box2D vector, and actually a pointer, so we can give out data. A reference works as well. So this is called vector. Then we need a center point, so this is again b2 vec2. This can be a reference or not, it doesn't really matter. This is the center. And lastly we need a angle, so float angle. Perfect. So now what I have to do is actually go online and do a search to rotation matrix. So rotation matrix, that's it. And you get to this Wikipedia page which shows you the rotation matrix in 2 dimensions. And if you go down here you can actually find it, actually the result of this multiplication. As you can see, x times cosine, cosine phi minus y times sine phi, x times sine phi plus y times cosine phi. So we can actually copy this, we can't copy this because this is an image, but actually just write down here this into our program. So I will make another vector, b2 vec2, and this one called TMP, because we can't use the vector to do the modification, because as you can see we will change the x coordinate if we would use the vector as the result of this formula, but in the when we calculate the y we need the x again, and we need the original x. So I create another TMP vector, and the TMP.x is equal to whatever is wrote in here. So let me just copy this into here. Okay, I just write down into here. The angle will be in radians, so that's not a problem, because sine and cosine in C++ waiting for the angle to be in radian, and then I just make the just make it equal the output vector equal to the TMP. I hope the assignment operator is overloaded or something. I don't want to make vector.x equal tmp.x and vector.y equals tmp.y. So I think this should work. or not, and we will see. Okay, and actually before I do that I have to add the center to it, so plus center. I think that is overloaded, the addition operator. Okay, and pretty much that's the function. So before I use the rectangle, so before I use the draw rectangle or draw square, whatever, in the display I use this rotate translate function. So right here, after I get the current point from the shape, I just use the rotate translate function, and this rotate translate function will wait for the point, which is point I, then waiting for as the next parameter the center, which is tmp.getCenter right here, and finally it's waiting for the angle, which is tmp.getAngle. Okay, that was pretty much it. It should work with SDL now, so we should try to compile it. Okay, I get the terminal. Here is one, and try it. Okay, and 96. I'm pretty sure I have missed a parenthesis and a semicolon. Right. Okay, and 125. So the problem is that the get word sender gives back a constant reference while I'm waiting for a normal reference. So I go here where I rotate, so translate rotate, and either just delete the reference sign and give it by value, or write the const here, which should solve the problem. And I'm pretty sure that's supposed to solve everything. And if I run this right now, then we would have a little bit of problem. It's a bit small. Why is it that small? I should scale it up by multiplying this by the meter to pixel, because now I try to handle meters as pixels, so I just multiply everything by meter per pixel, and that should do the trick. So here lastly multiply it by meter to pixel. Okay, and now if everything goes correctly, then we get almost the same result, except the polygons are not filled. Yeah, pretty much the same. And this uses only SDL, no OpenGL or no hardware acceleration for the rotation. Okay, and yeah, that pretty much should conclude it. One thing I should mention is that, as I already said, you can use images instead of lines, and in that case, if you are using images, you probably want to use some library like SDLGFX to actually rotate the object. And yeah, that's it. So thank you for watching, and